All right, so these videos we want to talk about determining when a function is increasing or is decreasing. So, in other words, we want to find out when the derivative is greater than zero or less than zero, because we know that when the derivative is greater than zero, then the function is going to be increasing. And we know that when the derivative is less than zero, the function will be decreasing. So since we need to know when the derivative is greater than zero or less than zero, we need to find the derivative. So we can compute that really easily because it's just a polynomial function. And so then what we need to do is determine when f prime is zero or when f prime is undefined. I want to explain about this a little bit. Why are we checking these places? So I want to look at a graph of a couple of functions here. So here we have the graph of this polynomial here, 4 minus x squared times x squared. And we can see that below -2 there, the graph is always negative. And then between -2 and 0, the graph is positive. And then after 0, it stays positive. And then finally, there at 2, it switches back to being negative. So what I want you to see is the only times this function can change from being positive to negative, or negative to positive, or vice versa, is when it crosses the x-axis. Now, just because it crosses the x-axis, or touches the x-axis, like it does here at 0, 0, doesn't mean that it actually will. Doesn't mean that it actually will cross there, just that it could cross there. So what we do is we're actually going to find these places where it is 0, and then we can actually test our intervals to see whether it's above or below. Okay, and a similar idea with this second function here. This is a rational function. This is going to be undefined when the denominator is 0, which happens to happen. Actually, I put the wrong one up there. I need to change the function here. If it'll let me. At 0 and at -4. And so what I want you to see here at 0, it has a vertical asymptote, and it actually doesn't change sign. But here at x equals 4, it has a vertical asymptote, and you can see it does switch from being negative to positive. So at vertical asymptotes, places where the denominator is 0, you can also change sign. But just because you can change doesn't actually mean that you necessarily will. So again, we look for those places where something's undefined. So that's why, going back to our problem here, we want to know when is f prime 0 or undefined, because those are the places where f prime could switch signs from positive to negative. And since we want to know when it's positive and when it's negative, so we know when it's increasing or decreasing, that's why we look at these values. So we find when f prime is 0. We can solve that very easily. 16x minus 20 equals 0. Bringing the 20 over, divide by 16, we get x equals 5/4. Now we do have to address the question of being undefined, but in this case here, f prime is never undefined because it's a polynomial. Sometimes you're going to have ones where you'll have some division by a 0 being involved. Other times you won't. And this is just a case where f prime is never undefined. So at this point, we move forward with our problem by taking that one value that we have, and we plot it on a number line, because we want to test now. Is f prime greater than 0 when we're below 5/4? Or is it less than 0? And same thing above. So here I compute f prime of 0. I can pick any value I want that falls below -5/4. It falls below my -5/4 here. I can pick anything I want. So I happen to pick 0 because it's easy to compute. And it's negative. So that means from 5/4 downward forever, f prime is always going to be negative. And so therefore, the original function f will always be decreasing. And likewise, we need to pick a value bigger than 5/4. I picked 2. If you plug 2 into the derivative, you'll get that it's equal to 12. 12 is positive, and so therefore it will be increasing over that interval. And then the last thing we want to do is not just make this chart, but actually write out the answer to the question. So we'd say it's increasing from 5/4 on to infinity, 5/4 to infinity. It's decreasing from negative infinity up to until it reaches 5/4. And when we do increasing and decreasing, we pretty much always have open intervals. We don't include the endpoints generally when we're talking about increasing and decreasing. Okay, until next time.